Hi there! In the following video I will show you the solutions to the Unit 2 AQA GCSE Higher Practice Paper 1. Okay, let's start straight away with an easy question 1. Estimate the value of 97.6 divided by 4.8 squared. Keyword here is estimate. Estimate means it's a sensible approximation to the answer. So you round every number you see to one significant figure. You look at this from the right. The 9 is in the tens column, so you round 97.6 to the nearest 10 and get 100. You look at the 4, you come over here and you look at the 4, it's in the units column. What's the nearest unit to 4.8? Well, it's 5, so this is 100 over 5 squared. That is 100 over or divided by 25, which is 4. So a good approximation or estimate for the answer is 4. Question 2. It says you are given that 32.7 multiplied by 26 is 850.2. Just out of interest, therefore, you know that 850.2 divided by 26 must be 32.7, and similarly 850.2 divided by 32.7 must equal 26. They are your associated division facts with that multiplication statement. 2a, write down the value of 327 times 26. Well, you know that 32.7 times 26 is 850.2, so you multiply the first number by 10, which means you multiply the answer by 10, so the answer must be 8,502. Part B, 85.02 divided by 26. What's that? Well, looking above, I said to you one of the associated facts with the first statement was 850.2 divided by 26 is equal to 32.7. So what have I done to this fact that I know to get to this fact? Well, I've divided the first number by 10. So I'm going to divide my answer by 10 as well, and I'm going to get the answer must be 3.27. Lastly, 2c, work out the value of 32.7 multiplied by 27. Now, students here might be tempted to launch into some long grid method or long multiplication algorithm to work this out. However, it's only 2 marks, so really you should be thinking, can I use something from above to help me? Well, you can indeed. 32.7 multiplied by 26 is 850.2. So therefore, 32.7 multiplied by 27 must be the same thing as above, 850.2, but adding another 32.7. Because in the original question, we've got 26 37.2s give us that. So now we're working out 27 37.2s, which is actually just one more 32.7 on top of the answer we already know. So the answer to this is 850.2 plus 32.7, which is 882.9. And that is your answer for 2 part C. Next question. This star here means that you're going to be assessed on the quality you write your solution down. So it's very important to be very clear how you work out your answers and state your answer to the exact question at the end. Joe sees some TV models in the sales of 2 different shops, in Googlebox and Square Eyes, and the question asks, which store sells the television more cheaply? So at the end you need to state which store that is. Okay, let's work out how much Googlebox is selling it for. So I would put Googlebox with a colon, and let's do some working to see how much it's selling for. Normally it's £390, but now it's 10% off. So an easy way to do it is to work out what's 10% of 390, and that is 39. So 30% of 390 must be 3 times 39. Okay, just a bit of working over it. Well, 3, if you're doing 3 times 39, you could do 3 times 30 plus the 9 times the 3, and you would get 90 plus 27, which is 117. So therefore 30% is 117. So sale price for Google Box is equal to 390, subtract the discount 117, and you would get yourself the answer £273. Okay, let's work out Square Eyes. What's Square Eyes selling price? Well, it's normally £405, but there's a third off. So we want to work out what a third of 405 is. So we can do 405 divided by 3. Okay, if you do that, you should get £135. So therefore the sale price is equal to 405 subtract 135, and you will get your answer for that being £270. So you need to state which is cheaper, so I would therefore say Square Eyes cheaper by £3, and that would do the job for you. Okay, next question. This is a simple substitution question. You just need to be very careful as you're substituting in. It tells you x is 27, y is -9, and z is 3. Work out the value of w given by this expression or equation. So let's work it out. W is equal to 5. Then multiplied by, well, x is 27, then subtract -9, and all of that is divided by 3. Well, let's do the brackets first. That's 5. 27 subtract -9 is the same as 27 plus 9, which is actually 36, and all of that divided by 3. Now, there are a long way and an easy way of doing this. You could multiply 5 by 36, okay, to start yourself off and get 180 over 3, which is 60. So your answer is 60. Or some people might like to divide the 3 into the 36. I'll do this down below. You've got 5 times 36 over 3. You could actually cancel that down so that you do the 36 divided by the 3 and get 12, and you're just left with 5 times 12 on the top, which is again 60. Either way works, and the answer is 60. Question 5. Another function machine question. We see a lot of these. You're putting in a number, you're multiplying by 3, you're adding 4, and you're getting an output. It says there is one value that gives an output twice the input. Let's write down what we want. We want output equals twice or 2 times the input. That will help us now work out what our number should be. Some pupils will like to put numbers in. So you put 1 in, you times 3 and get 3, add 4, you get 7, and is 7 twice 1? No, it isn't, so that's no good. I really would encourage you not to try putting random numbers in, because you could be there a long time and waste time. Instead, put some algebra inside to the function machine. For example, let's put in n, let's say. Your input is n. If you multiply n by 3, you get 3n. If you add 4, you then get 3n plus 4. So your output is 3n plus 4. What did we want? We wanted output equals twice input. So our output, 3n plus 4, must equal 2 times the input, which is n. And a mathematician writes 2 times n as simply 2n. Now we've got an equation, an algebraic equation. We can solve for n to work out what this input must have been for these two things to be the same. So I would advise you to subtract 2n off both sides. So you get n plus 4 is equal to 0. And then I would advise you to subtract the 4 from both sides to get n is equal to minus 4. And your answer, n is negative 4. Do check at the end you've got the right answer. If you put minus 4 in and times by 3, let's have a go. Minus 4 times 3 you get minus 12. Add 4 you get minus 8. So your output is minus 8. And that is double your input, so you know you've done it right. Question 6. Envelopes are sold in packs of 24. Address labels are sold in packs of 60. Holly needs the same number of envelopes and address labels. What is the smallest number of each pack that she can buy? So let's just try and down here write what's going on here. If she's buying envelopes in packs of 24, then her next set, if she bought 1 set, 2 sets, would be 48, 3 sets would be another 24, which would be 72, etc. And if she bought address labels in packs of 60, her first pack would be 60, 120, 180, etc. So if she wants the same number of envelopes and address labels, effectively what we're asking for is the lowest common multiple of 24 and 60. Okay, one way of doing it is to continue the list on here and see if we get any similarities. If I do the next 24, I would get 96. If I do the next 24, I would get 120. And 120 is the smallest number in both lists, so I would say that she needs 120 in total, but it's asking you how many packs that is, so therefore packs of envelopes that come in 24, she's going to need 5 packs, and packs of address labels that come in 60, she's only going to need 2 packs. Okay, you could answer that question using Venn diagrams and breaking or decomposing the numbers into prime factors and using Venn diagrams. However, it's a straightforward question. Listing the multiples until you see the smallest common one is the best there. But the key in this question really, for me, is reading the question because it asks for how many packs, not how many envelopes or address labels that would be. So make sure you read the question carefully there. Okay, question 7. A baby weighs 4 kilograms when he is born. 1 month later, he weighs 4.8. Work out the percentage increase in the baby's weight. Well, there's a formula for percentage increase that you should know. Percentage increase, or decrease for that matter, is equal to the new value, subtract the old value, over the old value, and then you multiply by 100 to make it a percent. Okay, so now let's do percentage increase is therefore 4.8 subtract 4 all divided by 4 times 100. Well, 4.8 take away 4 is 0.8 divided by 4 times 100. 0.8 divided by 4 is 0.2 times 100, and therefore you would get 20% as your answer. You could see that yourself if you were fairly clever at looking at the numbers. You could see if he started off at 4 kilograms, 10% of 4 kilograms must be 0.4 kilograms, and to go up in 1 month by 0.8 means you must have gone up in 2 lots of 10%, which is a 20% increase. Okay, next question. Question 8. Fairly straightforward algebra expansion questions here. Let's have a go at doing these. 5 subtract 3 multiplied by x minus 2. Key point here is to be very careful with that minus. What could go wrong here is that a pupil would do 5 subtract 3. This is what a pupil could do. They would do 5 subtract 3 is 2, and then they've got an x minus 2, and then they would say that's 2x minus 4 and write that answer down. That is not correct. If the examiner wanted you to do the 5 subtract 3 first, they would have put a bracket round that to tell you that. However, they don't want you to do that first. They want you to do the multiplication first. And I would encourage you to think of this number here as a negative 3. Negative 3, keep your 5 where it is to start with. Negative 3 times x is negative 3x. And negative 3 times negative 2 is a positive 6. 5 and 6 is 11, and you've still got your negative 3x. So 11 subtract 3x. Okay, expanding double brackets here. First term times first term of the second gives us x squared. First term times second term of the second gives us minus 5x. Then second term of the first times first term of the second is plus a 7x. And then the last terms are both multiplied gives us 7 times negative 5 is negative 35. Tidying up minus 5 plus 7x would give us x squared plus 2x minus 35. And that is your answer to question 8. Okay, question 9, another star question, just telling us we need to be careful how we lay out our working. It says the rule for finding the next term in a sequence is to multiply the previous term by 2 and then add k, where k is an integer. Integer means whole number, so a whole number. The second term is 15, the fourth term is 81. Work out the first term. With these type of questions, I would just encourage you to write each thing down to start with that's in the question and follow your nose in some ways, and that will help you. Writing down what the question is telling you will actually help you get started on this question. So the first term, that's what we're trying to find out, okay? But we know the second term is equal to 15. What's the third term? Well, it says that the rule in the sequence is to multiply the previous term by 2, then add k. So we can work out the third term. The third term is the previous term 15 multiplied by 2, and then you add k. So tidying this up, the third term therefore must be 30 plus k. Okay, well what's the fourth term then? Well, we happen to know what the fourth term is. It's 81. But let's use our knowledge of the third term to get another way of writing the fourth term. What do we do to get the fourth term from the third term? Well, we take the third term, 30 plus k, we double it, so I'm going to write the 2 here, and then we add k. If we do that, we get 60 plus 2k plus the other k, and we get 60 plus 3k. And that, just working down here, 60 plus 3k must equal 81, because we know the fourth term's 81. Well, let's use that to find k. Subtract 60 off both sides, you get 3k is equal to 21. Divide both sides by 3, and you get k is equal to 7. Hence you found k. Okay, well what's the first term? Well, the first term, in order to get the second term, we would have taken the first term, we would have multiplied it by 2, and then added k to get the answer of 15. So just writing that down here, to get from the first to the second, we would have taken the first term, we would have multiplied it by 2, then added k to get 15. So let's find this first term. Let's subtract 7 from both sides. 2 times the first term must equal 8. So therefore, dividing both sides by 2, the first term must be 4. And hence you've got your answer of 4. Okay, next question. Question 10. It's a question about inequalities and how they are drawn on the xy plane. The question asks us to basically work out which of these 6 inequalities describe this shaded triangular region here. The first thing to do in these type of questions is to actually look at the lines on the graph and label the lines using your knowledge of equations of straight lines. Well, Y is maths exciting and compelling is my question to you. What's that got to do with anything? Y is maths exciting, X, and compelling. Y is maths exciting and compelling. Y equals mx plus c is the equation of a straight line in maths. So you always use that formula to get an equation of a straight line. This is a great formula to use to work out what the equation of a straight line is. M is your gradient and C is your y-intercept, or where the line crosses the y-axis. Let's use this knowledge to identify these lines, starting here. This line here, well, the y-intercept C is 12. As you go across one, you go down 1.5, so your gradient M is minus 1.5, negative 1.5. Your equation of the line is y equals negative 1.5 x plus 12. Usually mathematicians don't like decimals in equations of straight line. It just looks a bit messy. So if we doubled everything, both sides of the equation, we'd tidy up that decimal and get 2y is equal to minus negative 3x plus 24. Also, that negative 3x looks a bit messy, so I'm going to add 3x to both sides to get 3x plus 2y equals 24. This is an equivalent description of the equation of that line. This is a good answer here, so is this, but this one's just a bit neater and tidier, and actually, we'll see later, looks like the one above that we need it to look like. Okay, let's go for another straight line. Let's go for this one here. Where does it cross? Well, C is equal to 4. As you go across one, you go up 2, so the gradient M is equal to 2. So the equation of the line is y equals 2x plus 4. Simple as that. Everything a whole number, nothing negative, so we'll just leave it as it is. Looks good. Let's finally go to this one here. Where does it cross? Well, C is 0. As you go across one, you go up 1. M is 1, so y equals 1x, or just x, plus 0 is the equation of that line there. Okay, now you think about whether the shaded region is above or below each of the lines you've written their equation for. Let's do this one to start with. The shaded region is above or on, because it's not a dotted line, the line y is x. So the shaded region is above or on the line y is x. Y is bigger than or equal to x is one of our answers. Hence E is one of the equations of the inequalities. Let's have a look at this one over here. The shaded region is below or on the equation of that line because it's underneath it. So y is less than or equal to 2x plus 4 describes the shaded region. Does that look like anything we've got above? Well, this says y is bigger than or equal to 2x plus 4, so it's not that one. In fact, it turns out to be this one here. Well, what they've done to get from here to here is subtract 4 from both sides, so they've made that y subtract 4 is less than or equal to 2x. These two are actually equivalent. One has just been subtracted 4 off both sides to get to the other. Okay, the last one, let's have a look at this one here. The shaded region here is below or equal to that line. Equal to because it's not dotted, and it's below in the majority of cases. So 3x plus 2y is less than or equal to 24. Well, which one's that? That's C here. So the answer for this was C, E and F. What you do for these questions, again, remember, label the lines using y equals mx plus c. If the shaded region is below the line that you've labelled, then it's a less than. If it's above the line, then it's bigger than. If it's dotted line, then it's strict inequalities, and if it's a full line, then it can be less than or equal to, or bigger than or equal to. Okay, question 11, nice easy algebraic manipulation here. Base numbers t are the same. T to the 4 times t to the 8 is t to the 4 plus 8, which is simply t to the 12. W to the 15 divided by w to the 3, base numbers the same, you subtract the indices, that must be w to the 12. And if we're simplifying fully this, what are we doing? We're doing 30xy to the 8 divided by 5x cubed y to the 4. Nicer to write like this, it makes things much easier. Well, what's 30 divided by 5? It's 6. Okay, we've got 1x multiplying on top and 3x multiplying on the bottom, so that one of them cancels and leaves you with x squared on bottom. We've got 8y's multiplying on top and 4y's multiplying on bottom, so 4 of the y's cancel and leave you with 4y's on top. So you get 30 divided by 5 is 6, you've got a y to the power of 4 on top, and you're left with an x squared on bottom. You can write that as 6y to the 4, x to the minus 2 if you prefer. Next question. Some algebraic fractions here. I'm going to show you two ways of doing this. The first way, if adding or subtracting fractions is your aim, make the denominators the same. 5 and 4, they both go into 20, so make the first one a 20. What have you done to 5 to make it 20? You've multiplied by 4, so multiply the top by 4 as well. Make the second number a 20. Keep your takeaway in there. What have you done to the 4 to make it a 20? You've multiplied by 5. So do the same to the top. Multiply the x minus 2 by 5. And you know that's equal to a half. Now, times out the brackets before you add or subtract. So 4 times 2x is 8x. 4 times 3 is 12. And then you've got 5 times, you're doing a takeaway. 5 times x is 5x. 5 times negative 2 is minus 10. That's over 20. That's over 20. And you get a half. Now, actually perform the subtraction. 8x subtract 5x is 3x. 12 subtract negative 10 is actually 12 plus 10, which is 22. So you have plus 22 all over 20 equals a half. Now to solve from there, multiply both sides by 20 to remove 20 from the left hand side denominator. So you get 3x plus 22 is equal to 10. Half times 20 is 10. Then subtract 22 from both sides to get 3x is equal to negative 12. Then divide both sides by 4 and you get x is equal, divide both sides by 3 and you get x is equal to negative 4 as your answer. So an answer there is x is negative 4. What you should do really then is check you've got the correct answer there. So if you had negative 4, you'd substitute it in and check you actually did get a half, and you do. Let me show you another way to do this question, just for some pupils who prefer this way. Remember, I've told you before that if you do something like 4 times 3/4, you get the answer 3, and effectively if you the 4 cancels with the 4 on the denominator and you get the numerator 3 left over. That's a useful skill to know about, because what some pupils like doing and sometimes find easier is to remove the fractions from the bottom of these equations first. So what they might do is they might say, I don't like the 4 here, so I'm going to multiply everything by 4. that will bring a 4 on top of this fraction. I get 2x plus 3 over 5. X minus 2 over 4 times 4 just gives me x minus 2. And a half times 4 is simply 2. Now I don't like the 5 on the bottom, so I'm going to multiply everything by 5. That will remove that 5. I'll still have the top 4x plus 3, subtract. Now 5 times this, 5 lots of x minus 2 is equal to 5 times 2 is 10. At that point they expand out here, so you expand this out, you get 8x plus 12 minus 5 times x is minus 5x, minus 5 times minus 2 is plus 10 equals to 10. Tidying up a little bit, 8x minus 5x is 3x, plus 22 equals 10. Subtract 22 from both sides, so 3x is equal to minus 12. Divide both sides by 3, x is minus 4. That again, we get that answer. Either way you want to do it, it's up to you. I prefer the first way because it's about making equivalent units on fractions when you add or subtract, but this is another way to manipulate your algebra to get the right answer. Question 13. Write this number in standard form. Remember, standard form is a number times 10 to a power. This first number here has to be between 1 and 10 strictly. So if we're going to write this in this form, the number we choose to represent this between 1 and 10, we'd have to have 6.187, and we multiply it by 10. Well, to what power? If I had put the decimal point there, I need to do 10 to the power of 1, 2, 3, 4, 5, 6, 7, and 8. So that would be your answer. Write this as an ordinary decimal number. Okay, well, the minus 3 tells us that there are 3 zeros to start with. Then you write your 904, and you put your decimal point always after the first one. So the answer is 0.00904. Question 14. Now this is a tricky question. Very involved question here. Try and follow me through if you can. Hope this is about as hard as changing the subject of the formula gets at GCSE. We want to make x the subject of the formula. So we want x equals to an expression over here, but with no x's in it anymore. We don't want any x's in this expression. So we want x equals something. Now currently there's an x on the numerator of a fraction and inside on the denominator. At some point the x's will have to all be on the same level, so they all have to be a numerator, for example. There can't be one on top and one on bottom. Also, the x is trapped within a bracket here, so at some other point in this process we'll have to take it out of its bracket. Then we're going to collect everything with an x in it. Then we're going to factorize, and then we're going to get the answer for x. So the first thing I'm going to do, I don't like the x on the bottom here, so what I'm going to do is I'm going to multiply everything by ma minus x. That will just leave me on the right hand side with just the numerator x, and on the left hand side I will get bma minus x, because b multiplied by this is bma minus x. Release the x from its brackets, so multiply out the brackets. That would give you bma minus bmx is equal to x. Now collect everything with an x on the same side of the equation now. So what I'm going to do here is I'm going to add bmx to both sides so that all the x's are together. It will remove the minus bmx here, so I'll get bma is equal to x plus bmx. There's an x as a factor here, an x as a factor here, so I'm going to factorize out the x. X divided by x is 1, bmx divided by x is bm, so I factorize that, and that's equal to bma. So what is x? X times a number is another number, so x must be that other number, BMA, divided by 1 plus BM, and hence you have your answer. X is equal to BMA divided by 1 plus BM. X being the subject of the formula. Question 15. Work out the values of A and B if this identity, the 3 lines here, is true. Usually easy to do these ones by expanding both sides of the identity fully and comparing coefficients. Well, the left hand side, this side, is already expanded fully. X squared plus AX minus 2. What about the right hand side? The right hand side, let's expand it out. X minus 3 squared minus B. That means X minus 3 times X minus 3, subtract B. Okay, let's keep going with that. That must be X times X is X squared, X times negative 3 is minus 3X, minus 3 times X is minus 3X, minus 3 times 3 is plus 9, take away B. So tidying that up, the right hand side must be X squared minus 6X plus 9 minus B. Now, let's just have a think about the left hand side and the right hand side. There's an X squared term, an X squared term, a term with X's, a term with X's, and a number term minus 2, and another number term 9 minus B. B is just a number. Right, let's just compare coefficients. The number in front of X squared here is 1, and it's 1 here, so that's fine. The number on the left hand side in front of X is A. The number on the right hand side in front of X is minus 6. For these two things to be identical, A must therefore be equal to negative 6. And next, the number term in this expression is negative 2. So negative 2 must be equal to the number term on the right hand side, which is 9, subtract B, which we don't know. Let's work out B then. In order to work out B, that 9 take away a number is minus 2. B, you can just spot, must be 11. So therefore B is 11 here. Question 16. Work out the value of y when this equation is true. I don't like the surd on the bottom here, so straight away I'm going to multiply everything by root 7 minus 1. To remove that surd on the bottom here. So I'll be left with the top. I'll be left with root 3 times y. I'm just going to write as root 3y is equal to root 7 plus 1 multiplied by root 7 minus 1. So root 3y is therefore equal to, well, some of you will spot this as the difference of two squares, a plus b times a minus b, where the answer is a squared minus b squared. Root 7 squared is 7, and 1 squared is 1, so subtract 1. So some of you will spot that, but others may need to expand this out here. So I'm just going to show you how to do that in case you're not sure. Root 7 times root 7 is 7. Root 7 times minus 1 is minus root 7. 1 times root 7 is plus root 7, and 1 times minus 1 is minus 1. These terms cancel, and you just get the 7 minus 1 is 6. So root 3y equals 6, so y must be equal to 6 over root 3. The question says write your answer in the form c root d. They don't want a square root on the bottom, so you multiply top and bottom by root 3, and you get 6 root 3 over 3. 6 divided by 3 is 2, so you get the answer 2 root 3. Hence the final answer is 2 root 3, C is 2 and D is 3. 17, last one here, quite a complicated one using this triangle notation we've seen before. It says two integers a and b are combined using the operation triangle in the following way. A triangle b is a squared plus a minus 4b minus b squared. Let me just try and give you an idea of what this means. Students seem to struggle with this notation. Whenever you've got two numbers, related by this notation A triangle B, it means you take the first number, you square it. You then add on the first number. You then subtract 4 times the second number, and then you subtract the second number squared. For example, if 2 and 1 were related in this way, I would square 2, I would add 2, I would subtract 4 times 1, which is 4, and I would subtract 1 squared, which is 1. And I would get the answer 4 plus 2 is 6, 6 take away 4 is 2, and 2 take away 1 is 1. Now, it's just confusing notation, but basically it's substituting whatever the first number is into this expression, whatever the second number is into this expression. So it asks you to solve the equation x triangle 2 is 0. Well, what does x triangle 2 mean? Well, it means you square the first number, so you do x squared. You add on the first number again. You subtract 4 lots of the second number, which is 2, and then you subtract the second number squared. Tidying that up, you would get x squared plus x minus 8 minus 4, so you would get x squared plus x minus 12. Now remember, you want to solve x triangle 2 is 0, so all the way along you make this equal 0, make this equal 0, make this equal 0. You have a quadratic equation equaling 0. So to solve, you can try and factorize. Two numbers that multiply to negative 12 and add to 1. Well, what times this to 12? Well, 12 and 1, can in any way they ever make 1? No. 3 and 4, can in any way they times to negative 12 and make 1? Yes, if you have 4 and minus 3. So you factorize as x plus 4, x minus 3 is 0. Two numbers multiplying to give 0. Either the first is 0, so x plus 4 is 0, in which case x is negative 4, or x minus 3 is 0, in which case x is 3. Your answers for x are therefore 3 and negative 4. Okay, last part of this practice paper, two integers a and b are still combined in this way. It says if a is 4 greater than b, prove a triangle b is a multiple of 5. Imagine I said to you, I'm thinking of this number 16. What is the number 4 greater than 16? Well, it's 20. How did you know? You did 16 plus 4. I've got this number 11. What number is 4 greater than 11? Well, it's 15. How did you know? Well, you did 11 plus 4. So I've got this number b. I want you to write down the number 4 greater than b. Well, how would you do it? Well, you would do b plus 4. So the trick here is to notice that to notice that a is a number 4 greater than b, so a is equal to b plus 4. That's the key to this question. So if you're working out a triangle b, it makes everything easier if everything's in terms of b. Why don't you instead, knowing that you know a is equal to b plus 4, instead work out b plus 4 triangle b? Well, let's substitute into the above to see. The first number squared, add the first number, subtract 4 lots of the second number, and then subtract the second number squared. If you multiply this out, let's do some working over here for some of you, but some of you may be able to do this quickly. B squared plus 4b plus 4b plus 16. So this simplifies to b squared plus 8b plus 16 plus b plus 4 minus 4b and then minus b squared. tidying up. B squared subtract B squared is nothing. 8b plus a b is 9b. Take away 4b leaves you with 5b. So I've dealt with those. And 16 plus 4 is 20. Always factorise to finish with. What divides into 4b and 20? Well, 5 does, so you're left with b plus 4 in the brackets. Hence, a triangle B is a multiple of 5 because it's 5 times a whole number. And hence, you've got the final question on proof, which is a tricky one. Thank you very much.